Hi everyone, welcome to the Unit 1.2 review video. Okay, so let's start on the section that will not have your graphing calculator on. In problem 1, they're asking us to classify and determine the number of solutions for each system of equations. So I can go ahead and take 4x minus 5y equals 0. And in these problems, I don't necessarily want to solve. I want to get them in y-intercept form or slope-intercept form in order to see what their slopes and intercepts are. So I'm going to get solve for y. So I subtract 4x, and I get negative 5y equals negative 4x, and then I divide by negative 5. So my first equation is equivalent to 4 over 5x. Okay, my second equation, I can solve for y by subtracting 8x from both sides first. And I end up with negative 10y equals negative 8x plus 15. Then you divide everything by negative 10. And you end up with y equals 4 over 5x minus 5 over 3. I'm sorry, minus 3 over 2. Okay, so if you notice, the slope of this line is 4 over 5, and the slope of this line is 4 over 5. Now, the y-intercepts here is negative 3 halves, and this one doesn't even have an intercept. So we are dealing with lines that have the same slope, but different intercepts, which means that they are parallel, right? So they will never intersect. So the answers to number 1 is inconsistent and it has with no solution. Alrighty, moving on to number 2. The first equation's already in slope-intercept form, so now let's move the second equation to be in slope-intercept form. I've got to move the 2x over to the other side, so it becomes negative 2x. And then I have to divide everything by negative 1, so I end up with y equals positive 2x minus 7. Okay, well, you notice that, again, the y-intercepts are negative 7 and positive 7. So they have different y-intercepts and different slopes. Well, automatically, if they have different slopes, you can go ahead and assume that they will intersect, and that means that they're consistent and independent with one solution. Alright, now moving on to number 3, let's move this first equation to y-intercept form. We've got to move the x over to the other side, so we end up with negative 3y equals negative x plus 1. Then we divide everything by negative 3, and we end up with y equals 1/3 x minus 1/3. Alright, and in this second equation, we need to move the 2x over. So we have negative 6y equals negative 2x plus 2. Then we divide everything by negative 6. Okay, so you end up with y equals 1/3 x minus 1/3. Alright, well, you notice that they have the same slope, so we know that they're consistent. Or, I'm sorry, same slope. And we know that they have the same intercept. So we know that they are the same line. Okay, and if they're the same line, that means that they're always intersecting. So they do have a solution. In fact, it's dependent because they are always intersecting. They have infinitely many solutions. Alright, so now let's move on to the next type of problem that will be seen on your test, which is graphing the equations. So once again, I like to get this in slope-intercept form, but if you choose to graph by your intercepts, that's fine also. So I'm going to change this to be y equals negative x minus 5. And I'm going to change this one. I need to move the positive 2 over, so it's negative 2y equals negative x minus 2. And then I can divide both sides by 2, so I get y equals 1/2 x plus 1. All right, so the two equations that I'm going to be graphing are y equals negative x minus 5 and y equals 1/2 x plus 1. So I know my y-intercept for the first line is negative 5. So I plot that point, and then I use my slope, which we know is negative 1, and that means I'm going to go over 1 and down 1. So it's going to be decreasing to the right by 1 unit each time you move to the right. Okay, so there's the first equation. And then the second equation has a y-intercept of 1 and a slope of 1/2. So I'm going to go over 1, down 2. Oh, I'm sorry. I'm going to rise 1, go over 2. I apologize. Rise 1, run 2. And then you're going to go ahead and connect those points with your straight edge. Hopefully your lines will be a little bit straighter than mine on test day. And if you notice, where the lines intersect is your solution. So my solution to this problem is negative 4, negative 1. Right at that point right there. Okay, let's move on to problem number 5. X equals 8 is going to be a vertical line because every point on that line has to have an x value of 8. So if I just wanted to have a couple points with an x value of 8 and then draw that line. Okay, and then the next equation is already in slope-intercept form. So I'm going to go, my y-intercept's at negative 5. So I'm going to plot my point at negative 5. And then I'm going to rise 1, run 2 from that y-intercept point. And then if you notice, the lines intersect at 8, negative 1. Right at that point right there. So my solution is 8, negative 1. Okay, so those hopefully will be easy enough. You just graph the equations of the line and find the intersection point. All right, moving on to solving each system of equations algebraically. We can go ahead on number 6. I'm going to go ahead and use the process of elimination because I notice if I multiply my top equation by 4, I end up getting negative 20x, or sorry, positive 20x. Sorry, let's multiply it by negative 4. We're going to try that again. So I get negative 20x plus 4y equals negative 12 when I multiply that top equation. And then I'm going to keep my bottom equation the same. And what happens here is you get the x's eliminate. That was the whole goal. And then you end up with 0, another 0 pair with the y's, equals negative 24. Well, this is a false statement. So the solution is the null set. There is no solution to this problem. Okay? All right, so number 7, we have x and y in our denominators of both equations. So what we're going to focus on is our numerators, and I'm going to use elimination again. And looking at my x's, the numerators over my x's, I have 4 and 2. So I can multiply this bottom equation by negative 2, and I can end up with negative 4x minus 12 over y equals 6. And then I can bring down my top equation of 4x plus 5y equals 8. Okay, and what happens here is these x's get eliminated, and you end up with negative 7 over y equals 14. Okay, so now that tells me my y value is equal to negative 1/2. So then I can take my negative 1/2 value and plug it back into one of my equations. And when I do that, I end up with, I'm going to use the original bottom equation. So 2 over x plus 6 divided by negative 1/2 is the same thing as multiplying 6 by negative 2. Dividing by a fraction is the same thing as multiplying by the reciprocal. So 6 divided by negative 1/2 is actually negative 12. And then that equals negative 3. So now when I go ahead and move that 12 over, add 12 to both sides, I end up with 2 over x equals positive 9. Then you can end up cross multiplying and you get x equals 2 over 9 as your solution. So my ordered pair, my solution to this system of equations, my x value is 2 over 9 and my y value is negative 1/2. All right, moving on to problem number 8. We're going to go ahead and use elimination here because if you notice, I have a negative 4/3 y and a positive 4/3 y, so that just eliminates. So when you bring down 3x, and then that's going to be equal to 7/3 minus 7/3, so that's going to be 0. So then you divide both sides by 3, and you get x equals 0. So now we just plug it back into one of our equations. So I can go ahead and plug back into the top equation. 2 times x would be 2 times 0. So it's really 0 equals negative 4 over 3y plus 7/3. Well, then what happens is I can bring that 4/3 y over to the other side, and it becomes positive 4/3 y equals 7 over 3. And then I need to divide by 4/3, which again is the same thing as multiplying by the reciprocal, 3 over 4. So y ends up equaling 7 over 4. So my solution is 0, 7 over 4. Alrighty, let's move on to the last two problems, 9 and 10, where we're solving algebraically. Okay, so I'm going to take my top two equations right now, and if you notice, the z's are positive and negative, so I know that that's going to be eliminated. So I'm going to take 2x plus 3y minus z equals 5, and then x plus y plus z equals 9, and the z's cancel, and that ends up giving me 3x plus 4y equals 14. Okay, so that's the first equation that I can use to go ahead and have eliminated a variable of z. Now I can take my second and third equation, x plus y plus z equals 9, and x minus 2y minus z equals negative 7. And notice that the z's eliminate again, and I end up with another equation with x and y in it, which gives me 2x minus y equals 2. So now I have two equations with two variables in it, so I can set those equal to each other. 3x, or set up a system with those. 3x plus 4y equals 14, and 2x minus y equals 2. Okay, then I need to eliminate the y's. You could eliminate the x's, but the y's seem to be easier if you multiply by 4. So you end up with, when you do that, 3x plus 4y equals 14, and 8x minus 4y equals 8. Okay, so now when that happens, the y's cancel. You end up with 11x equals 22. And then you divide by 11. So x equals 2 in this system of equations so far. Okay, so now I can go and plug that back into one of my top equations. So, or one of the two equations with x and y in it. So I can plug it in to 3. Instead of x, I can multiply by 2 plus 4y equals 14. So that's 6 plus 4y equals 14. Subtract 6 from both sides, and you end up with 4y equals 8. So y, in this case, also equals 2 when you divide both sides by 4. So now we know what y is, we know what x is. So we can go back up and plug into our original equations and solve for z. So let's go ahead and use the middle one. It seems to be the easiest. X plus y plus z equals 9. So I'm going to plug in 2 for x and y. And I get 4 plus z equals 9. So z equals 5. So the key there was taking two equations, eliminating a variable, and then taking one of those equations in the third equation that you didn't use the first time and eliminating the same variable to give you two equations with two variables, so you set up a two-variable system of equations. Okay, and then you just continue to find values and plug them in to solve. Okay, on this last one, we can use elimination by multiplying. I'm going to rewrite it over here for some more room. Multiplying the top equation by -5 in order to get our x's to eliminate. So let's multiply this top one by -5, and you end up with -20x plus 25y equals 15. Okay, so let's go ahead and rewrite our second equation to where the equal signs line up. So I'm going to bring this 25y over to the other side. So I end up with positive 20x, and then now positive 25y plus, or sorry, equals 15. So now, oh, I'm sorry, when I multiplied the top equation by -5, that should have become -25 there, and this should have become -15. Okay, so what happens is you get 3 zero pairs. So 0 equals 0, which is a true statement. And when you get down to that, that means that any ordered pair, so we can write it as x, y, any ordered pair will be a solution to this equation as long as it falls on one of these lines. Equals xy such that 4x plus 5y equals 3. Essentially, these two lines in problem number 10 are the exact same line. They're coinciding lines that will be graphed on top of each other that makes them always intersecting. Now, some of y'all will be tempted to put all real numbers, and that is wrong because all real numbers is not the solution to the system of equations. The solutions are all the points that lie on that line, or these two lines, which happen to be the same thing. Okay, so let's move on to the next part, and we'll finish up this review. Now, the next part is without your calculator, so be prepared to put your calculator away at this point in your test.